Hi you guys, Miss Onay here, just wanting to bring you a flip video to go over everything that we talked about yesterday in depth and actually how we can just double check that we're on the right track, okay? So this is kind of going to be a review video, but I want you to watch the whole thing because after this, today is going to be a practice day where you just work through problem after problem so you know you're comfortable for the quiz Thursday. So please watch this whole thing. You can take extra notes on the pages or you can just listen, but just please get through the whole video, okay? So I'm going to be casting what I write up on the board, so you actually won't see me, but you're going to see what I'm writing, okay? So let's get started. The first thing that we need to be weary about is the rules and the steps in which we look at reactions. First, you want to assign A or B, whatever that may be. Then you want to look at the charges, and then you want to balance the equation. In a lot of the classes yesterday, we made sure that we could look at the charges, or we made sure that we could get our product, but we did not balance. So today we're going to practice doing all three of those. So first, you guys, I want you guys to turn to page 31. We were a little bit rushed yesterday when we got through these. However, we're going to just go over a couple examples of all 5 of these types of reactions, just so we're all on the same page, because we're going to do this by charge, and by charge it's just much easier. So we're going to start with synthesis reaction. This is one of the easier ones. Synthesis reactions is A plus B forms AB. So I'm taking 2 smaller compounds or elements and combining them together to get my final product of AB, okay? So the first example that you guys have on your paper is H2 plus O2 produces what? So I know we've already gone over this, but let's just talk through this as a refresher. So my element A is going to be hydrogen. My element B is going to be oxygen. I'm not worried about these subscripts. I just want to know what is hydrogen and oxygen. So I know that I have to combine these two, hydrogen and oxygen. But HO doesn't make sense, right? I need to look at my charges. Hydrogen is a +1. Oxygen is a -2. If you crisscross those, you get H2O, right? So you should get H2 plus O2 produces H2O. But now you're going to see I have 2 hydrogen here, 2 hydrogen here, 2 oxygen here, and only 1. So I know I have to balance. So I definitely want to put a 2 in front of this guy to get 2 oxygen on this side. But that bumps my hydrogen up to 4, so all I have to do is put a 2 over here, and now I'm balanced, okay? Synthesis reactions are very straightforward, but we are going to consider charges in all types of reactions. So we're going to move right along to decomposition reactions. Decomposition reactions are pretty much the opposite of synthesis. AB breaks down into A plus B, okay? So this is an example that I gave to 5th period, but this one is one that you don't have on your paper. So let's try and break this down. So if I give you AlCl3 and you need to find A and B, the first thing I'm going to do is say, okay, the element that I see here, the first one is Al. So I know I have to have aluminum, and the second one I see is Cl. Do I care about this subscript? No. However, we need to think here because Cl, if you remember your diatomic elements, Cl is part of Hofbrinkel. So I need to make this a Cl2. If it's on its own, you make it diatomic. So now am I balanced? 1 Al, 1 Al, good. 3 chlorine, 2 chlorine. Nope. So in order to balance this guy, I know that I need to make both of these a multiple of 3. So I'm going to put a 3 in front of this guy. That's going to get me 6Cl, which means I need to put a 2 here. And then I have 2 Al, so I need to put a 2 here, and now I'm balanced. Okay? So decomposition reaction, you just take the 2 pieces, break them apart, add a diatomic subscript if necessary, but these ones are pretty straightforward. All right, now we get to the part where charges really matter, and this is something that we didn't talk about in depth yesterday. So yes, this is the pattern that I see, but what I really want to talk about is why these charges matter. So we're going to do actually 2 examples here. We're going to do example 1 on page 32, but I'm going to alter it a little bit. So I am going to use AgNO3. Again, my 5th hour we did this. Instead of Cu, let's change this to Mg because Cu is a transition metal and we don't know the charge of that unless they tell me. So Mg, charges matter in single displacement, okay? Charges are key. So Mg has a charge of +2. NO3, if you guys look, has a charge of -1, and Ag is one of my common metals to have +1. Okay, so I'm good to go. Now, single displacement, instead of assigning A and X and B, yes, we can do that, and then you can follow this formula and make Bx plus A. That is totally fine if that's the way that you want to do it. However, that means you're going to have to memorize all of these formulas, and we don't want to do that. The easiest way to do this is I want to combine my lone cation with this anion, okay? So whatever your lone element, whatever that is, this guy needs to get back into the game, okay? So I know for a fact that Mg is going to be part of my compound. So what can Mg bond to? Can it bond to Ag? No, they're both cations. Can it bond to NO3? Yes, this is an anion. Mg has a charge of +2. NO3 has a charge of -1. If I crisscross, you would get MgNO3 2. And then what is my lone guy left over? This time the lone guy left over is silver, okay? I have looked at my charges, I now have my products, and now is when I balance, okay? So you guys can go ahead and balance it on your own, but what you're going to get is you're going to get 2, 1, 1, 2, okay? So let's do another example here. We're going to look at this simple one right under it, NaI plus S. My charge of Na is +1, my charge of I is -1, my charge of S is -2. So, what can I combine this lone guy with? I know S has to get back in the game, but is S a cation? No, it's an anion, so I know it has to become a compound with this cation. What comes first, metal or non-metal? The metal does, so I know I'm going to put Na, this has a charge of +1, and I have S combined, this is -2. That will give me, after I crisscross, that will be Na2S. What's left over? The only guy left over is iodine, and if we think hot sprinkle, if it's ever by itself, this needs to be I2. Okay, so let's check if I'm balanced. I've got 2 I's over here, so I'm going to put a 2 here. I've got 2 NA's here, 2 NA's here, 1 sulfur, good to go. Okay? So that is single displacement. You are looking at charges is the easiest way to combine. You want to combine a metal or a cation, right, with a nonmetal or a polyatomic ion, and you want to do that with something that's negative, which is an anion. Okay? So make sure you're taking that into account. You don't want to just say, okay, this is element B, so S goes first here with Bx. No, S cannot go first. It's an anion, okay? So please, please, please be careful, okay? So from here, we're going to move on, and we are going to move right on to double displacement, okay? Double displacement, I only got to this, I think, in one class, and even that, we need to definitely go over this with some practice by looking at charges. Again, here, charges are the best way to go. Like single displacement, I'm trying to combine a metal with a nonmetal or a polyatomic ion. However, in this case, I want to do it twice. I'm not going to have one lone guy, okay? So let's start with example number 1. You have PbNO3 2 plus NaI goes to what? So the first thing you do is establish charges. PbNO3 2. We know NO3 is a -1 charge, and this 2 is here telling me that Pb is a +2. NA, I know that NA is a plus 1, that I is a minus 1. So now I need to make my two products. Again, I want to combine my positive with a negative and my other positive with another negative. It doesn't matter which order you go in first. I'm just going to pick the first one that's positive, and that's PB plus 2. It's already paired with this negative. You don't want to do that twice. So this time I'm swapping this guy out, and I want to go with the second negative. So I'm going with I, which is a negative 1. If you crisscross those, you get PBI2. Plus, now I've used PB, that's my first positive. My second positive is NA plus 1, and my second negative here is NO3, which is a minus 1, so those two will cancel out, okay? So I'm good to go there. Now my products are presented, but now I need to balance, okay? I have 2 NO3 here. This is my object of interest. It has the most amount of things here, and I only have 1 over here, so I'm going to put a 2 in front of this guy. And now that makes me have 2 sodium, and I need 2 sodium here. That gives me 2 I's, and I already have 2 I's there, and there's 1 lead, good to go. You should have 1, 2, 1, 2. Okay? So let's try another example. Let's look at example number 2. We've got NaCl plus CaSO4, and that goes to what? So first thing you do, you're going to look at charges. Na is plus 1, Cl is minus 1, this is plus 2, this is minus 2. So from here, I've got to pick a positive to go with a negative. So I'm going to start with my first positive, that's Na. It's already bonded with Cl here. I don't want to use the same one, I want to use the other negative. And this is SO4, and SO4 is a 2 minus charge, so this should be Na2SO4. Now I just do the opposite. I have Ca left, that's my positive, that goes first. And then I have Cl, which is a minus 1. You crisscross, you get CaCl2. To make this balanced, I have Na2SO4. This is my object of interest. I need a 2 here to get 2 Na. That gives me 2 Cl. I have 2 Cl. I have 1 calcium, 1 calcium. I have SO4, SO4. So I'm good to go. Let's just walk through this last one together. If you guys are just, this is a review, then that's totally fine. Just keep on listening. We've got FeS plus K2CrO4. Fe has a charge of plus 2. If you look in your common charges. S has a minus 2, and then we have K is a plus 1, and then we have CrO4 to be a minus 2, okay? So now I need to pick my first positive, that's Fe, that's a plus 2, and combine it with my second negative, which is CrO4, that's a negative 2, so I don't have to crisscross anything, they just cancel. Plus my second positive, which is a K, that's a plus 1, and then I've got S, which is a minus 2, that's going to be K2S. Okay? Sorry, lights just kind of flickered there. So, we're good to go. Now we're going to move on to combustion. Combustion is everyone's favorite because all you have to do is make sure that you have a hydrocarbon to start with, which just means a compound that has hydrogen and carbon in it, and then you know your reactant has to have O2 and your products have CO2 and H2O. So example number 2, you guys, example number 2 says burning octane, C8H18. That is my hydrocarbon. So now I just finished writing this, plus O2 goes to CO2 plus H2O. Okay? So before I go anywhere else, I have to balance this. And I'm going to tell you this guy is a doozy to balance, but where I would start is I would say, okay, maybe I should make, this is my object of interest, maybe I should make this over here an 8. So if I were to try that, I would find out that it wouldn't work and that I'd need to multiply actually everything by 2. So in the end, your final answer would be 2, this is 25, 16, and this is 18, I believe. So I'm giving that to you, but all you really have to do for this is copy O2 produces CO2 and H2O and then balance. Okay? So what I want to do now is please turn to page 34. Okay? What you guys are going to be doing for the rest of today is working on pages 34 and page 33. Now, I want you to work on page 34 first. Do this first. Then I want you to check your answers in with the sub. She has a key. And then do this page second, okay? This is just good practice. This, you guys want to get as much of this done by the end of the period. This will not be homework. However, the better you do on this, the better you will do on the quiz. So I want to start with you on page 34. I just want to do the first couple with you just to make sure we're all good on predicting products, okay? So let's start on page 34, the first one. You can see here that they are giving you the names of the products, or they're giving you the names of the reactants, but you actually have to write the reaction. So copper 2 sulfate. Copper 2 sulfate, that's Cu, that means it's a +2 charge, and sulfate, SO4, that's a -2, so I can just leave it as is. Then it says plus magnesium fluoride, MgF. Magnesium is a +2, fluoride is a -1, that gives me MgF2. Now, I need to figure out what products are being produced. Now here you could be like, Miss O'Neill, they're giving me 2 compounds. What do I do next? How do I know if I need to make 2 more? Do I break it down? I'm confused. They're telling you that you need to produce 2 more compounds, okay? If you have 2 compounds like this and you're producing 2, then you know this is a double displacement question, okay? This is a double D. So from here, if I'm doing double displacement, I know that I need to combine my first positive with my second negative. So Cu is a +2 and F is a -1. So you get CuF2. Then I combine my second positive, Mg, +2, and combine it with my second negative, SO4, which is 2-, it's just MgSO4, okay? Now before I leave, I have to balance this equation. I have 1 Cu, 1 Cu, 1 S, 1 S, 4 oxygen, 4 oxygen, 1 Mg, 1 Mg, 2F, 2F. This is already balanced, I'm good to go. Okay, let's do number 9 together. Here, I have calcium, it says, and it's not with something else, so just calcium, plus lithium iodide, okay? Lithium has a +1, iodide is a -1. Goes to, and they tell me there are 2 things that I need to produce. I have 1 element on its own and then a compound, so I know this has to be single displacement, okay? So here, I have my positive. This guy's by itself. He needs to get back in the game. So I have a positive. My positive, does it go with Li or does it go with I? It has to go with a negative, so it wants to go with I. So Ca, this is a +2, and then I have I, which is a -1. You crisscross, you get CaI2. And then that leaves you left over with lithium, plus lithium. Lithium is not a Hofbrinkel element, so I leave it as is. Can I be done with this question? No, I have to balance. I have 2 I's here, 2 iodide, and I only have 1 here. I'm going to make this a 2. That brings me 2 lithium. There I go. 1, 2, 1, 2. Okay, I'm going to do silver, this number 10 with you, and then you guys are on your own. So, silver acetate, that's Ag, that's a +1. Acetate is C2H3O2, that is a -1. Plus, lead 2 nitrate, lead 2, that's a +2. Nitrate is an NO3, that's a -1. If you crisscross, you're going to get PbNO3 goes to, and they give you 2 products. I know that this guy has to be double displacement, okay? So, I put my positive, my first positive with my second negative. That's going to be Ag, that's a +1. And then I need to go with my second negative, NO3, that's a -1, so it's just going to be AgNO3. Then I'm going to take my second negative, or my second positive, that's Pb. I know that has a charge of +2. Combine it with my first negative, which is C2H3O2. So that is a -1. If I put that together and I crisscross, you should get this, PbC2H3O2 parentheses 2. Okay? Now, am I done yet? No, I have to check if I need to balance. This guy is definitely my object of interest. There's a lot going on here. I have 2 of C2H3O2. So the first thing I need to do is put a 2 over here. I need 2 of these entire things. So 2 here, that means Ag has to be 2. Then Pb, there's 1 here, there's 1 here. There's 2 NO3, and I just put a 2 here, and that goes to that NO3, so now I'm balanced. Okay? So I hope that helped you guys. You need to work through page 34 first. Check your answers, then look through page 33, okay? So if you have questions, please email me, but it's all about the charges, okay? Don't forget that. Look at the charges and you will be fine. This is not that hard. It's only hard if you try to do it by memorizing formulas. If you look at the charges, you can do it, okay? So you guys have the rest of the period to work on this. You have no homework. This will not be collected for homework when I come back tomorrow. But the more that you have done, the better our review will be when I see you tomorrow. Okay? Bye, guys. Have a great day.